Hi, our project is on building scalable and robust distributed systems by increasing access to blockchain and ledger databases. So here is my team, myself Lakshmi Samhita Atluri and my partner is Sairam Pangaluri. Ara is a data exchange platform. They have created like a way to connect small farms in developing nations to banks and distributors of goods like seeds, fertilizers, and tools. Traditionally, rural farms have been ignored by the financial world because they don't normally have the information required to open an account or apply for credit. With Hara, it's hard to obtain data on small farms, so as collected and authenticated, giving these farmers access to resources they have never done before. Let us see how Hara helping farmers to improve their lives. As we know that Hara launched the Hara Data Exchange platform in 2015 to improve the lives of the smallholder farmers in Indonesia. Whereas these Hara field officers, they collected several types of farmer-related data, such as crop planting and harvesting through a mobile phone app. This Hara incentivizes the farmers to provide the data by offering them loyalty points for the information. The farmers redeem the points via the Hara website for mobile phone credits and discounts on agricultural supplies. In the future, farmers will be able to redeem their points for advisory services to increase the productivity and the quality of the crops. Let's see, experiencing the limitations of an on-premises infrastructure. At first, Hara's ID infrastructure ran on an on-premises server. It took days to configure and stabilize new servers. They wanted a more scalable IT infrastructure. At that time, only AWS offered a stable Python 3.0 runtime to connect their external library for geospatial data formats. A major component to the system that Hara created is blockchain. This is a technology used to build applications where multiple parties can interact through a peer-to-peer network and record immutable transactions with no central trusted authority. However, building a scalable enterprise application on a blockchain today is so time consuming and complex. To remove the complexity associated with the blockchain networks, they used Amazon Managed Blockchain, a fully managed service that makes it easy to create and manage scalable blockchain networks. And they also use Amazon Quantum Ledger Database, Amazon QLDB. It's a ledger database that provides some of the same features as blockchain for data integrity. It's designed for centralized systems where there is a central trusted authority. Amazon QLDB provides a transparent, immutable, and cryptographically verifiable transaction log owned by a central trusted authority. Let us first see like what is actually a blockchain. Blockchains are designed to maintain the integrity of data. They are immutable, like which means committed data history cannot be altered or deleted. It can only be updated. A blockchain is essentially a shared database filled with entries that must be confirmed and encrypted. An easy way to understand is to think of it as a highly secure and verified Office 365 document, each docu entry dependent on a logical relationship to all its predecessors. The name blockchain refers to the blocks that get added to the chain of transaction records. To facilitate this, the technology uses cryptographic signatures called hash. What is a ledger basically? Ledgers are typically used to record a history of economic and financial activity in an organization. Many organizations build applications with the ledger-like functionality because they want to maintain an accurate history of their applications data. For example, tracking the history of credits and debits in banking transactions, or verifying the data lineage of a insurance claim, or tracking movement of an item in a supply chain network. Finally, ledgers help to make blockchains immutable. Ledgers have been around for a long time and were typically used to record a history of economic and financial activity between two or more parties. Earlier civilizations such as Mesopotamia and ancient Egypt used ledgers built with stones and papyrus plants. Today, a banking application that tracks credits and debits is one of the most common example of a ledger.
Need for Amazon managed blockchain. Blockchain makes it possible to build application where multiple parties can execute transactions without the need for trusted central authority. Today, building a scalable blockchain network with existing technologies is complex to set up and hard to manage. To create a blockchain network with each network member need to manually provision hardware, install software, create and manage certificates for access control, and configure networking components. Once the blockchain network is running, you need to continuously monitor the infrastructure and adapt changes, such as an increase in transaction requests, a new members joining or leaving a network. These difficulties are overcome by using Amazon Managed Blockchain. What is Amazon Managed Blockchain? Amazon Managed Blockchain is a fully managed service that allows you to set up and manage a scalable blockchain network with just a few clicks. Amazon Managed Blockchain eliminates the overhead required to create the network and automatically scales to meet the demands of thousands of applications running millions of transactions. Once your network is up and running, Managed blockchain makes it easy to manage and maintain your blockchain network. It manages your certificates and lets you to easily invite new members to join the network. What is the need for Amazon QLDB? In general, ledger applications are often implemented using custom audit tables or audit trails created in relational databases. However, building audit functionality with relational database is time consuming and prone to human error. It requires custom development. And since relational databases are not inherently immutable, any unintended changes to the data are hard to track and verify. Alternatively, blockchain frameworks such as Hyperledger Fabric and Ethereum can also be used as a ledger. However, this adds complexity as you need to set up an entire blockchain network with multiple nodes, manage its infrastructure, and require the nodes to validate each transaction before it can be added to the ledger. What is the Amazon QLDB? Amazon QLDB is a new class of database that eliminates the need to engage in the complex development efforts of building your own ledger-like applications. With QLDB, your data's change history is immutable. It cannot be altered or deleted, and using cryptography, you can easily verify that there have been no unintended modifications to your application's data. QLDB uses an immutable transactional log known as a journal that tracks each application data change and maintains a complete and verifiable history of changes over time. QLDB is easy to use because it provides developers with a familiar SQL-like API, a flexible document data model, and full support of transaction. QLDB is also serverless, so it automatically scales to support the demands of your application. There are no servers to manage and no read or write limits to configure with QLDB. You only pay for what you use. Ledgers found in blockchain typically consist of the following two. One, current and historical state. It is a data structure that keeps the current and historical state values, allowing applications to easily access the data without needing to traverse the entire transactional log. A journal. It is a transactional log that keeps a complete record of the entire history of the data changes. The transactional log is append only, meaning that each new record is chained to the previous, allowing you to see the entire lineage of data chain history. Additionally, with the help of cryptographic hashing, a process that assigns a unique identifier like a fingerprint to each record, blocks are chained to one another. This allows Ledger to have a timekeeping property, allowing anyone to look back in time and get proof that the data transaction occurred, making this makes auditing simple. Here, the shown figure describes a ledger database. And compare this to relational database where customers have to engineer an auditing mechanism because the database is not inherently immutable. Such auditing mechanisms built with relational database can be hard to scale. In addition, developers have to work hard to ensure that all the right data is being recorded. In addition to a distributed ledger, blockchains also include a consensus mechanism and smart contract execution environment. Consensus algorithm helps to ensure that the members in the network have an agreed upon method to allow transaction and data to be committed to the ledger. If the consensus requirements aren't met, then the transaction is rolled back and not valid. Smart contracts are programs that have the rules and penalties of engagement for a contract defined into lines of code. The program continuously checks when the conditions for a contract are met or not. If the contracts are met, then the contract automatically gets executed. Together, these elements allow two or more parties to transact with decentralized trust, where each party consents to the transaction and records the transaction. Decentralized trust makes sense when multiple organizations must independently verify transactions history and have a single up-to-date accurate view of data. It also makes sense when there is no single party that wants to maintain an application but network members still want to transact with other parties efficiently. The figure describes about central trust authority and decentralized trust. In central trust authority, a single globally trusted server determines the trust values of every node in the network, not the same in decentralized trust. Enabling the stakeholders to operate with the decentralized trust improves efficiency and cut down cost. A single participant does not own infrastructure, and the system describes a copy of the transaction ledger to each participant for independent verification. The business contract, such as letter of credit, can be written as a smart contract in the blockchain application. It can automatically execute as soon as all parties provide consensus to record the transaction. Customers look to blockchain as a technology that enables them to transact with multiple parties when there is no single trust authority and they need a system with decentralized trust. Now, making blockchain easy with manager blockchain. As we discussed earlier, it is very difficult and expensive and time consuming to create and manage blockchain network using existing frameworks. First, to create a blockchain network with permissions, each network member must manually provision hardware, install the software, and create and manage certificates for access control and configure network components. When the blockchain network is running, users have to continuously monitor the infrastructure. They must adapt to changes such as an increase in transaction requests or new members joining or leaving the network. To help overcome the barriers that the people face trying to build using blockchain, AWS has created managed blockchain unlike a self-hosted blockchain network. Amazon Managed Blockchain eliminates the need for manually provisioning hardware, configuring software, and setting up networking and security components. This service allows users to set up and manage scalable blockchain network with just a few clicks. It automatically scales to meet the demands of thousands of applications running and millions of transactions. Managed blockchain manages certificates and tracks operational metrics such as usage of compute, memory, and storage resources. With managed blockchain's voting API, network participants can add or remove members. When a network member requires additional capacity for creating and validating transactions, the member can quickly add a new node using managed blockchain's API. In addition, managed blockchain provides a selection of instance type that comprise varying combination of CPU and memory. This gives you the flexibility to choose the approximate mix of resources to support your nodes. Users pay according to their usage and don't worry about any upfront cost for infrastructure. Managed blockchain supports two popular blockchain frameworks, Hyperledger Fabric and Ethereum. In Hyperledger Fabric is well suited for applications that require heightened privacy and permission controls with a known set of members. For example, this might include a financial application where certain trade related data is only shared between a subset of a network, only the bank that are part of the trade. Ethereum is well suited for highly distributed blockchain networks where transparency of data for all members is important. Each transaction is visible to all members of the network. For example, this might include a customer loyalty blockchain application that allow any network retailer to verify user activity by broadcasting the transaction to all members. This is the figure of Amazon managed blockchain network with for Hyperledger Fabric. Uh, Managed blockchain creates a network and manages its key components like members, Hyperledger Fabric, Certificate Authority, CA for each member, and peer nodes and ordering services. And now see the working of managed blockchain. A blockchain network is a peer-to-peer network running a decentralized blockchain framework. Each network includes one or more members, which are unique identities in the network. For example, an organization in a consortium of banks. Each member on the network can easily create their own peer nodes that come with a variety of compute and storage options. With each member, the Hyperledger Fabric CA also gets created. The Hyperledger Fabric CA provides a number of certificate services that relate to user enrollment, transactions involved on the blockchain, and TLS secured connection between users or components of the blockchain. The peer nodes of each member interact to run smart contracts known as chain code. In Hyperledger Fabric, they create and endorse transaction proposed in the network and store a local copy of the ledger. Members define the rules in the endorsement process based on the application's business logic. For example, in a trade finance application, the bank for the exporting party wants to verify that the importing party has necessary funds before endorsing the transaction. To configure blockchain applications on peer nodes and to interact with other network resources, members use a client configured with the AWS CLI or SDK. Those network resources could include the certificate authority, ordering service, and peer nodes. Manager blockchain provides endpoints to access these services, which can be accessed via an AWS private link endpoint. Additionally, in managed blockchain, we have improved the Amazon have improved the reliability of the default ordering service, a component that ensures delivery of transactions across the blockchain network. They have built the ordering service using same underlying technology as Amazon QLDB. There is even now an immutable change log that accurately maintains the complete history of all transactions in the blockchain network, ensuring that customers durably save this data. A ledger solution with centralized trust. Amazon spent a lot of time at AWS talking to customers about blockchain to better understand the problem that it solves. Something interesting that they found is that many companies are interested in blockchain because they need a ledger that is transparent, immutable, and cryptographically verifiable. However, they don't have a use case that requires decentralized trust. One example of this is a department of motor vehicles that tracks vehicle ownership and registration history in a way that is resilient against data manipulation. People have tried to solve this problem with relational database, but it's not built to be immutable. Users have to do a bunch of work to create any complex auditing functionality. Also, with a traditional database, there is no way to go back in time and verify the integrity of the change log. Logically, the next thought is, what about the ledger component of blockchain? This solves the problems around data integrity and audit functionality in addition to providing decentralized trust for transactions involving multiple parties. For companies that don't need consensus on every transaction across all parties, it's not the right tool for the job either. The solution for this problem is a centralized ledger that serves a transparent, immutable, and cryptographically verifiable transaction log. That's why Amazon first created the Amazon QLDB. Amazon QLDB makes it easy to understand how application data has changed over time, eliminating the need to build complicated audit functionality within the application. An Amazon QLDB journal is an immutable log where transactions are appended as blocks of data. After transactions get written as a block into a journal, it cannot be changed or deleted. It becomes a permanent record. These blocks are also hash chained together using cryptography. This allows you to verify and show the proof of your data's integrity. For example, an e-commerce business may have to show proof of winning bid. This transaction then gets updated in the current stable state, which always keeps the current value of the data. And finally, the transaction gets indexed in the history table, which can be queried to track how the data has changed over the time. Additionally, because Amazon QLDB is a database, it provides better performance and scale than blockchain frameworks. It can easily scale up and execute 2 to 3 times as many transactions as common blockchain framework. Amazon QLDB is now available in limited preview. In this picture, we can see the structure of the Amazon Quantum Ledger database. As we discussed earlier, it has a kernel state and indexed history data structure and a journal, which is chained.
What are the benefits of Amazon managed blockchain? We can see like it's a fully managed service that makes it easy to create and manage scalable blockchain networks using the popular open source frameworks Hyperledger, Fabric, and Ethereum. Blockchain makes it possible to build application where multiple parties can execute transactions without the need for a trusted central authority. Today, building a scalable blockchain network with existing technologies is complex to set up and hard to manage. To create a blockchain network, each network member needs to manually provision hardware, install software, create and manage certificates for access control, and configure networking components. Once like the blockchain network is running, you need to continuously monitor the infrastructure and adapt to changes such as an increase in transaction requests or new member joining or leaving the network. Amazon Managed Blockchain is a fully managed service that allows you to set up and manage a scalable blockchain network with just a few clicks. Amazon Managed Blockchain, it also eliminates the overhead required to create the network, and it automatically scales to meet the demands of thousands of applications running millions of transactions. Once your network is up and running, managed blockchain makes it easy to manage and maintain your blockchain network. It manages your certificates and lets you easily invite new members to join the network. Let us look into Amazon QLDB. It is also a fully managed ledger database that provides a transparent, immutable, and cryptographically verifiable transaction log owned by a central trusted authority. It's a new class of database that eliminates the need to engage in a complex development effort of building your own ledger-like application. As we have already seen that QLDB, with this QLDB, your data's change history is immutable. QLDB uses an immutable transaction log known as journal that tracks each application data change and maintains a complete and verifiable history of changes over time. It's easy to use because it provides developers with a similar, like familiar SQL like API, a flexible document data model, and full support for transactions. It's serverless, so it automatically scales to support the demands of your application. There are no servers to manage and no read or write limits to configure. With QLDB, you only pay for what you use. Making modern ledgers available to everyone. Like blockchain and the ledger technology has the potential to dramatically improve many types of transactions. However, if it isn't accessible to everyone, many great ideas may never be realized. With managed blockchain and Amazon QLDB, anyone can create a ledger that is transparent, immutable, and cryptographically verifiable. There are many use cases for blockchain and ledger databases. Here are just a few examples. Let's look into the summary. By using these two solutions, Hara reduces IT costs by 60 to 70%, cuts IT capital expenditure, gains runtime and execution time support, and enables any server scaling. These two solutions, Managed Blockchain and Amazon QLDB, expand the AWS portfolio of databases that offers the most breadth and depth of any cloud provider by creating more options. And here are our references.